Hi, today on the bench next to me we have this beautiful HP oscilloscope. It's a type 54600B, 100 MHz, just 20 mega samples. Let's hear him power up. Oh yeah. Alright, well, as you can see it's a dual trace oscilloscope. The bandwidth is 100 MHz, but it's only got 20 mega samples. So it's really not that great for measurements of things that are not periodic. Above perhaps 10 megahertz, which is the Nyquist frequency of 20 megasamples, if I'm not mistaken. This puppy is in a pretty good condition. As you can see, it's powered up normally and it measures fine. But I made this video, and I am making this video right now to show you it and to talk a bit about it. It has a little bit of problems. Firstly, it doesn't have a handle. I can't find any replacements though, so we'll have to live with it. Secondly, the encoders are a bit jumpy. If I go one direction, it's all messed up. I'll show that to you in a second via the self-calibration menu, or self-test menu actually. Thirdly, the fan is pretty loud. This can be heard in the room while it's operating. It's a little bit frustrating. Thirdly, I'd like to give it a little bit of a cleanup, and perhaps consider replacing some of the electrolytics once we are inside. Let me bring you a little closer. Here we can see in all of its glory the self-test menu. It allows to test many of the buttons, all of which work just fine. Let me just twist this encoder one direction. As you can see, it thinks it's both directions. This one is a little better. This one as well. I'm twisting them all clockwise right now. And this one is a little buggered up as well. So the first channel is clearly a little tired. Yeah, it's interesting. Anyway, let's restart it. So that's gonna be... And let's try this keyboard test once more in the opposite direction. And in the opposite direction. Oh, no, it registered both ways. Let's try all the... horizontal is tired as well, which is expected. And it's tired as well. Well, so our offenders are these mostly, and that's what I'm gonna try to tackle right now. Alright. The fan in this unit is quite noisy, but it also means business. It's through the ventilation, to the holes that are left by the non-present handle. I cannot make this paper stick any closer. It's getting blown away. There's a very noticeable draft coming out of that hole. While we have him nice and operational on the bench, I can show you one interesting feature of these units. It features Tetris. We can move around and just play Tetris, you know. I'm absolutely not gonna attempt to play Tetris though, so let's leave that for now. But as an interesting side note, it does include such a little game. It's very fun. I do really love this, although the 20 megasamples per second are a bit of a letdown, but I do really like this scope anyway. To get into this unit, we just have to unscrew these two Torx screws, which are guiding it. Finding the right side screwdriver, the right side bit actually, was a little bit of work, as I don't really keep my bits tidy. Anyway, now that we have those unscrewed, this should just slide right out. Okay, allow me to just push him out. And here we go. He is out of his nest. Now, I'm going to put this enclosure on the ground and just let the unit slide out from it. Which it does. Oh my god, I'm a fucking idiot. Alright, anyway. Here is the scope in all of its glory. The noisy fan, the metallized enclosure, the CRT unit, the power supply, and under that the actual doodad that does all the thinking. Now, the electrolytics inside look quite good. Let me bring you in. Now that you're brought a little closer, you can see that all of them look relatively new and modern and seem to be from a pretty reputable brand. And because I am not seeing any concerning wobble on the screen or any other concerning things, I think I'm just gonna leave them be. On a side note though, here's something that's a little concerning. This looks like there was water damage at some point. This is the top of the enclosure, and I will try to clean it up now. We'll start with water, and then we'll get to something a little more aggressive, perhaps, if water doesn't work. While I was at it, I tried cleaning up other parts of the scope and noticed that this metallization has become quite fragile. I hope it's gonna stay where it is, and it doesn't seem like it is staying very well. Either way, I'll try to clean up some of this, which is revealing an issue. The metallization is very, very weak by now. So I think we will stick to water. Here I have some paste that's meant to wash hands. It's got a little bit of detergent on it. I'll try to sprinkle some of it on the wetted towel in hopes that it will help up cleaning the enclosure from the outside. This has worked quite alright, and it's looking a little cleaner now. Although nothing too crazy, nothing to really write home about. I'll have to try to clean this off, as this was once a sticker clearly, and for that I'll use isopropyl alcohol. We'll see how that works. I tested it on the back of the unit, and isopropyl alcohol doesn't seem to have a detrimental effect on the finish of this paint. So now let's try get that sticker off. I'm trying to see if any of the things that I don't like about this could come off with this new method. I have brought back the main unit here, and now we will try isopropyl alcohol on here as well, because there is also a sticker mark over here. Well, it does seem to be coming off. I'm trying to see if any of the other stuff would. Now I'll continue this on the rest of the face. I have limited storage available on my device. So if I want to record this whole video, I gotta be smart about it. And it has cleaned up quite alright, although it's nothing to write home about. Some things do persist, and I'll show you that a little later. But I'll try to tackle these knobs and get the grime in these grooves in just a second. But before we do that, let's move on to the fan. Here is the fan and some accompanying fun. Here I tried to use the screwdriver I just used to dismantle this thing, and well, appears they have used the same size Torx head screw, so that's very, very nice of them indeed. Now I'll try to remove this fan and compare its performance with the new one I got, and only if I'm sure that the new one will be able to cool this thing just as good as the old one am I gonna actually replace it. The connector here I just unplugged without no problem. Here it is. I've measured its RPM, and I'll talk to you about that in a sec. Now here's the subject of our investigation. It doesn't turn too freely actually. Well, some of that is just the magnets in the little motor that it has snapping. Either way, here's the new one I have, which does appear to spin a little more freely. Thing is, The new one has far less power than this. This is about 4 watts, while this is just below 1 watt. Hence, I'm concerned this one will not be able to perform as good as this one. I will see about that in just a sec, though. I've measured the RPMs on this bad boy. These do look really similar, don't they? I mean, they're just fans, but everything, the shape of the fins is quite similar. Maybe the amount of fins is similar. Yeah, there's 7 on both, so that's pretty nice, I guess. I've measured the RPM by just listening on a spectrum analyzer to the lowermost frequency that this guy gives out. Turns out it's about 280 hertz. I associated that with the rotational movement of the fan itself, and hence 280 hertz equals to about 17,000 RPM. Somewhere 17,400 RPM or somewhere like that. I don't remember. You just have to multiply it by 60 to get the rate per minute, not per second. Anyway, this has a little more, I think. I don't remember now, but I remember I looked at it on the website to make sure, and it runs faster and moves nice amount of air. I think like 58 cubic meters per hour. I don't know how much this bad boy moves per hour. I suppose because of their construction being very similar, I would expect this to outperform this one, but then the power is far lower, so perhaps this performs worse under heavy load when trying to push air into something that's resisting it. Anyway, I have a power supply right here next to me. I'll show you that in a second, and we will try to compare both of these. Here we have a linear power supply that should indeed be operational. That's very nice indeed. And we should set the voltage to somewhere in the range of 12 volts. Let me just try to really set it up nice. Okay. And then we have this one. This is the power supply is set up as a bipolar one right now, but that doesn't matter. We're not gonna be using it as such. And so we can now all right, we don't have output yet, right? So if I do this, all right, the fan is spinning. The other one is not, because I just noticed that it has a little, well, I've noticed this before, I just haven't thought about it, right? So I'll have to get to the contact somehow, which is not gonna happen with these alligator leads. A wise man always keeps some copper around. Perhaps this is not a lot of copper. We'll have some more copper right here, but either way, a wise man keeps around some copper. I hope this is gonna fit. And it does. Very, very good. Excellent news. Alright, I'll try to bend this out so it's not this easy to short it. This other one is cooperating a little less. Oh yeah, this other one is cooperating a lot less. Okay, well maybe I can get it to work anyway. Maybe. Oh yeah. Oh yeah. Oh, okay. Well, I think I've already have the result of the test. Well, my poor little fan can never perform this good. Oh shit. I mean, it's not comparable. This one is blowing air, this one is like not doing anything. It's it's really difficult to express just how big the difference is. Like this bad boy, alright, it's doing something. This bad boy, alright, well, it's doing a lot more. I don't know. It's not really that visible actually, the difference between the two, but it's fucking staggering in person. Alright, look, this boy, this thing, oh yeah, the fingers flapping and everything. Yeah, so I think we are not going to be replacing the fan, sadly. There you are. Well, then I must try to somehow make it a little more silent, I hope. You might be wondering what all of this is about, because there's a lot of mess on the table and some goop. Well, I'm trying to glue a transformer together because it delaminated, and it takes a little bit of work. So yeah, but the fan comparison not comparable. I need to find one that pushes 5 watts and really moves air around. That kind of sucks. But I guess I'll stick with the original now for now. And we will continue on with the cleanup. And just then my device ran out of memory. So naturally I had to delete about 5 gigabytes of pictures of my loved ones. And that freed only about 2 gigabytes. Thanks Apple, I wonder what you're doing with my storage. Anyway, I have some contact cleaner here, which should do the job. I also have a headlamp now, because I would like to see what I'm doing. I believe I can enter into the back of these little buggers in here and just spray them down. I think that's what I'm gonna do. Oh, this guy goes first. Let's try it. See what fucking happens. Try to not get it everywhere, but it's really trying to get everywhere. For example, on the CRT, well, that CRT is really happy about this whole thing. I think it really liked that the new friend it just made. Okay, maybe a little bit of it in here as well. Now this is gonna be a lot of the same, so I'm gonna spare you this, but this is what I'm gonna do. I might bring you a little closer to show you what I'm actually doing. Sorry for blinding you, by the way. So here they are, the rotary encoders from the back. You can also probably now tell why I have the flashlight on, because without anything, well, it's quite difficult to see what's happening. Anyway, you can oh my god, what the fuck? My flashlight is unhappy, it's running low on battery. Anyway, here they are, and I see a small tiny little gap right about here. Oh god, can you see anything? Am I blocking it all? Here's a tiny little gap, and I'm spraying it here, and maybe I can spray it in here as well, because there's an opening there that I believe to be even wider. Yeah, even wider than the one that I have mentioned previously. So I spray some and I turn the knob, and then we're gonna power it on and see if it did anything. So after all the ungodly things that I've done to it, it still boots. Let's try to see if we can actually, where was it? Service menu and self-test menu, and let's try the keyboard menu. Let's try this. This guy was an offender for sure. Now it's... Oh no, it didn't help. Oh no, it did not help. I am very, very let down. Alright, well now let's look about, how about this one? Oh no. They're all buggered up. They're all buggered up. Oh. Well, maybe this one works at least. Looks promising. Yeah. So these guys are a little annoying. By the way, when I sprayed stuff into this, I noticed something rather interesting. Well, actually, this is not a problem because it's still tracking rather nicely. I noticed something interesting. This one now moves a lot more freely than these. You can probably tell that I'm not able to move this at such a speed. And this one, I don't know, there must have been some sort of a little doodad that would have helped it move a little less erratically, would sort of introduce a little more friction, because these do certainly feel a lot more resisting the movement that I'm trying to insist on them. Either way, the big encoders have been fixed, which is very good. Just the small ones still remain a little buggered up, but well, especially this one now that it's no longer feeling all that premium and stuff. Either way, I'll now go to clean up the knobs, and we will call it a day. And we are back to the opening shot. The oscilloscope now cleaned up a little, and the encoder is working a little better. I decided to feed it something a little more interesting than the signal we had before, which is the signal from this pulse generator, which is quite frankly not that great. Look at him. He's constantly messing up. Yes, I believe maybe the potentiometers are messed up inside of him. I don't know. But I try to squeeze the absolute shortest pulse times to challenge this oscilloscope at all. It seems to be mostly unbothered. We could perhaps stop it right here and investigate a little more. Ooh. Okay, so I didn't know this, but this oscilloscope can't zoom in once it's stopped, I think. Or perhaps I'm just doing it wrong. Either way, this is some sort of a signal. We could actually try to measure the frequency, which is 3.2 megahertz. This guy claims that it can go a little higher, but I don't think so. It doesn't look higher. I don't know if this is a... What is this? Maybe this is actually... Well, look, he's thinking a lot now about what he's displaying. Perhaps I could... Interesting. Well, there's clearly something happening here. I would have to cross-check this with another oscilloscope to make sure. I'll actually do that now. Well, the other oscilloscope I have has a much harder time getting through on the phone. Actually being visible. Even on maximum intensity, but it also cannot make out what this generator is trying to say right now. I've tried setting it closer or more far away. I move the trigger around and I can't really see. Let's see what a modern oscilloscope has to say. Here we have fired up working modern Rigel. Well, seems that the generator is just spitting out gibberish. The Rigel is the only one that can actually tackle this task without failing miserably. It seems that, yeah, no wonder they are both freaking out. It's absolute nonsense what the generator is speaking. We could even try to run an FFT, perhaps. Yeah, let's try it. Take me a little moment to set it up. Well, I can't really make out anything valuable in this signal that's coming out. So, I am not really surprised that the HP can't handle this. The Rigel clearly can. It's got a 1 gigasample, so say like 50 more than this, so I am not that surprised that it can handle this. Either way, can now maybe actually make it work normally. And here we go. That's the expected behavior. Okay, well, I can turn off the math now, please. And just enjoy a normal oscilloscope experience. Okay, so, well, they do appear to agree in some sense, although the waveforms do look slightly different, which is very peculiar, yes. Oh, I'm gonna sneeze. Oh, maybe. Oh, I did. Okay, anyway. Woo, it works. There's a bizarre difference. I don't know why. The input... Oh, yeah, no. No, actually, it's very similar. 13 picofarad. Yes, 1 mega ohm. Yes. Now it's looking a lot more similar. Interesting. Oh, I thought my space ran out on my phone. Boy. Hey, this is a family portrait from vacation. Hey, it's working. Nice. I'm bringing it back home now. It's gonna be my lab in my home lab. These are the workhorses here in the garage. By the way, I believe you might have noticed that the skin of my finger is peeling off. I don't know why, but I believe that the fact that I use isopropyl alcohol a lot today is gonna help it very much. So yeah, it's troubling. I don't know what's up with that. Anyway, HP oscilloscope forever.